Muito obrigado. Eu acho que é um bom início do debate e talvez você pudesse, então, dar uma contribuição a mais nessa discussão.
Okay, I have a few slides. Let me. Yes, he knows me. Yeah, get me the next one. The issue of adaptation in the tropics, I think it has to do with what is the most important characteristic of climate. You know, in the mid-latitudes, people are really interested in what will be the weather, what will happen to the daily weather when climate change will appears. But in the tropics, I think the most important variation will be at seasonal and sub-seasonal time scale, is what will happen to the seasons and to the change of the season that is going to be more important in the tropics than elsewhere on the planet. And this changes almost everything. I mean, it changes because this means that you have to look for different factors when you try to evaluate what will be the impact of climate change. Of course, other things are similar. You know, extreme events are going to be also important. So what will happen to severe storms, tropical cyclones, storm surges? This is something similar. What will happen to agriculture and ecosystem? What will happen to coastal zone protection and management? In the end, everything will be developing into integration, into integrated risk models. Because all these kind of let's call them estimation, will be probabilistic in nature, will have an inherent uncertainty that will have to be assessed, and therefore it will be most useful when it is inserted into an integrated system and you will be able to evaluate risk. So that is the framework in which we are working. And of course, adaptation has severe limitation. If Holland goes underwater, we can probably convince the Dutch cows to do that, but I'm not guaranteeing about the quality of the cheese afterwards. So there are all sorts of aspects that you have to consider in adaptation. So you have to develop tools. You have to develop tools that are capable to simulate what will happen at the climate on such different scales. So you have to consider, for instance, detailed ocean forecasting. This is important because it will enable you to give an estimation of what will happen to your prediction capability under climate change. Climate change is like a theater. You'll change the back scenario, and things may change when you start to do something different. Next. Oh, go. This is an example of an integration. What I mean, this is a project that the Ministry of Environment of Italy funded in the Adriatic in Montenegro. What happened here, what we were able to integrate atmospheric climate model, urban waters model, coastal area model, river basin, underground water, and ocean model into an integrated system, and they allow the monitoring and the forecasting and the evaluation of the climate impacts over such an integrated zone. So we will have to evolve from a sectorial evaluation of what climate is in all different pieces into giving a complex and integrated picture that then will be useful in order to try to evaluate actionable. That's what I call actionable science. This will be information that can be used into evaluating policies and trying to develop strategies. Next. This is detailed. This is the kind of technology you have to develop. You have to put models of increasing resolution that go into the river. This is quite an advanced field, very exciting, by a lot of details. And the other thing we need to develop is a seasonal forecasting system, because the variation at seasonal time scale are so important. That is just a schematic. Details are not important of the seasonal forecasting system we have at CMCC. And this allows us, go next, to do seasonal forecasting of the Earth that we then downscale to a specific region, and we, of course, people are now experimentally trying decadal forecast, trying to grasp any skill that is there. And this is much more important because, as Carlos was saying, this is an issue that will stay with us, either that because our target is the variability, either natural or anthropogenic. And if it is anthropogenic, then we'll have to understand what will happen to this prediction capability under climate change. The red area is where we are really capable to predict. So you can see it's a complex problem. We are not able to predict everywhere with the same quality. So it's a difficult issue. And these are elements of what might be the basis of a collaboration between Italy and Brazil on the science on climate change adaptation. I think we can put together things that regard seasonal forecasting, climate variability, ocean prediction, and marine safety. This is really important in the context of protection and management of the emergency at sea, including oil spills. Because we have systems that are capable to predict the evaluation of the spills and the oil, including spills at depth. Landslides, floods, and climate change. We've been developing some schemes in Italy that can be used to evaluate the risk of landslides and the flash floods against the backdrop of climate change. We have to look at deforestation, forest degradation. This is a very important issue. I think Riccardo will say something more. And the other thing is that in the climate change impact on the river system and the coastal zone, this is something that we develop quite a lot in Italy and Mediterranean. I think there are several areas here in Brazil where this can be actually useful. And the other important area is the climate change impacts and adaptation for the agri-food systems. Again, this is another example of integration. We need a lot of different expertise and in order to achieve some meaningful results. And I think we should develop a vigorous visitor exchange programs at all levels, both junior and senior, so that we can foster the exchange between Italian and Brazilian scientists. Okay. And that's really all I have to say. So thank you very much.